I'm Lalit Manam, and in this video, I'll be presenting our paper on correspondence reweighted translation averaging. This work is done jointly with Venu, Madhav, Govindu at the Computer Vision Laboratory, Indian Institute of Science. Translation averaging is the problem of solving camera translations given pairwise relative directions. Due to the nature of input, the solution is defined only up to scale and the choice of origin. It also assumes known rotations so that all the directions can be placed onto the common coordinate frame of reference. Why need correspondences in the problem? Existing methods use consistency of input directions. These input directions are obtained from epipolar geometry, which are error prone. The performance of averaging methods are thus limited by the input quality. We argue that improved accuracy of translation averaging methods should be leveraged to mitigate the errors of input translation directions. Given these ideas, we propose a framework to incorporate point correspondence in the problem. Given a set of initial translation directions, generally obtained from epipolar geometry, we first solve for camera translations. Then we obtain a globally consistent translation direction from the estimated camera translations. These globally consistent directions are better compared to the epipolar geometric estimate due to the global view instead of the limited to view in the epipolar geometric case. Using these globally consistent directions, we weight each point correspondence on every edge. And from these weighted point correspondences, we re-estimate the relative translation direction and then solve for translations. To further understand, we define the following notations. Given an underlying view graph as G, each node represents a global rotation and translation Ri and Ti, and each edge represents a relative rotation and translation direction Raj and Tij. The relative translation direction can also be represented in the global frame of reference if the absolute rotation is known. We also define kth point correspondence in the edge I, j as Pij and Qkj. It is well known from epipolar geometry that the point correspondences are related by the relative motion in this fashion, which can further be rewritten in this form if we know the absolute rotations. Our formulation is to minimize this expression over all point correspondences and over all edges with weights for each point correspondence. These weights are obtained based on the global consistency of translation directions. Our method can be summarized as follows. Given initial global translations, we first update the weights for each point correspondence over every edge and then solve for camera translation directions using these weighted point correspondences, and then finally get the camera translations from these estimates of directions. And we repeat this process until convergence. We use two representative translation averaging formulations in our schemes. The first compares the displacement vectors and the second compares the directions. The dot product and the zero centroid constraints fix the scale and the origin ambiguity in the problem. We now present results of our scheme. It can be seen that with our scheme, the translation estimates improve on the respective averaging scheme used. Moreover, Greta Bata improves both on mean and median metrics for camera translation errors. It can be seen that the reprojection errors also reduce significantly when using our solution for triangulation when compared to the other existing methods. Also, it can be seen that most of the structure is recovered just in the triangulation phase when compared to the bundle adjusted reference. To conclude, we propose a framework CRETA which incorporates point correspondences in the problem. It iteratively defines global translations by reweighting point correspondences using global consistency, and it is modular, which can be applied to any existing averaging method, and it improves the reprojection errors with triangulation without any use of bundle adjustment. Thank you.